Hello and welcome to this video about SORRIR. Basically, SORRIR is two different things. First of all, it's a research project carried out by a consortium of 2 universities and 2 companies in Germany. It is funded by the Federal Ministry of Education and Science. My name is Jörg Domaszka and I've been the project coordinator for that project for more than 2 years. Secondly, SORRIR is an openly available software framework to implement resilient IoT applications. Obviously, the framework is the outcome of the research project. The reason why we address resilient IoT applications is due to the fact that IoT has evolved tremendously over the past. These days, IoT systems are spread out over a large geographical domain. We see IT components being applied in the field like sensors and actors, and we see parts of the IT infrastructure in the edge of the network. Of course, we also see IT services running in the cloud, like with the hyperscalers of AWS, Azure, or other kind of cloud providers. And while this is very exciting from a distributed computing point of view, it also has some downsides. The systems are so heterogeneous and widespread, and consequently they are very vulnerable to many different things, as many things can go wrong. If the cloud provider goes down, we have a problem. If the communication fails, we have a problem. If the edge gateway goes down, we have a problem. And this is an issue as IoT has become ubiquitous and has spread out to cover many parts of our daily lives. Hence, IoT has become a crucial part of our infrastructure, and due to that, we want and we expect IoT systems to be stable, i.e. resilient. And of course, resilient mechanisms exist, but they are difficult to implement and it requires huge expertise. And this is a problem as businesses expect high velocity and agile techniques to be applied so that new features can be rolled out regularly. Adapting resilience code to changed application behavior and testing all different kinds of error cases is cumbersome, error-prone, and expensive. Therefore, SORRIR has the vision to divide application logic from resilience logic. In particular, the goal is that people are able to implement their application without even thinking about resilience, and then, at runtime, adapt the resilience features as is needed. The problem here is that code and resilience mechanisms need to match. Particularly, many resilience mechanisms have very subtle requirements towards how the code has to look and behave so that they're able to work. In order to address that vision, SORRIR suggests a 4-step process. In the first step, users would compose an application from individual components. In the second step, they would enhance the application with resilience features. And in the third step, that resilient application would be deployed on the infrastructure. But of course, as in IT, this is not a static environment. Things will change, the application will change, new features will show up, but also requirements towards resilience will change as the application is growing and new infrastructure is being used. Finally, also problems in the infrastructure may show up, so operating systems may need patches or individual devices may need to be changed. In order to support that features, the SORRIR architecture consists of 3 major building blocks. On the application layer, it provides a programming model that defines how to build and compose the individual components. On the runtime layer, it provides communication channels, the resilience library, and also isolation features, ensuring that if one component goes down, other components will not be affected. And on the lowest level, the runtime environment, it provides packaging mechanisms that turn the components into deployable, executable components. It provides supporting services, and it provides extensive monitoring so that people are able to understand what is going on in the system. In the following, my colleagues will do a deep dive into individual parts of SORRIR. We will compose an application from its individual components, and we will apply that application to many different error scenarios. And for each of the scenarios, we will see how easy it is to adapt the application so that it can handle the respective error case.